Hello and welcome to part 2 of Mr. Brown's revision, and it's on moments this time. So we'll start us off with some definitions. So the first one is the definition of a moment. It's the force times the perpendicular distance between the pivot and the line of action of the force. Okay, so you must remember the perpendicular distance between the pivot and the line of action of the force. So to just demonstrate what that means, if we take a bolt with a spanner, okay, and we're going to apply a force to the end of the spanner, okay, there's the pivot in the middle of the bolt, so the perpendicular distance between that is the distance between those two dotted lines. Part B, you need to know what the definition of a couple is, and it's the total moment caused around a point by a pair of equal but opposite forces. Okay, so opposite direction. And in order to work out what a couple is, you use the equation where it's the size of one force times the perpendicular distance between the two forces. Now again, just to demonstrate it, imagine a steering wheel where the pivot point is in the centre, and if you apply a downward force on one side and an upward force on the other of equal size but opposite directions, the couple would be the size of one force times the distance between those two forces. And the last part is the principle of moments. Now this is quite important, quite often for a number of marks. So you have to say, for a system in equilibrium, the sum of the clockwise moments must equal the sum of the anti-clockwise moments around any point. It's also true that the resultant force for a system in equilibrium is zero as well. So the clockwise moments must equal anti-clockwise moments, and the resultant force is zero around an equilibrium system. Okay, a question. Now the easiest way is just to consider a simple seesaw. Okay, so you've got one person sat on the left hand side and you've got another person sat on the right hand side. Now let's say this first person has a weight of 800 newtons, the second person has a slightly less weight of 600 newtons. The pivot point will be the centre where the seesaw rests. So you need to know the distance. The distance from the left hand side to the centre is 1.2 metres, and the unknown distance is the other one. So work out which one causes clockwise and anti-clockwise moments, then apply the principle of moments. So in equilibrium, the sum of the clockwise moments equals the sum of the anti-clockwise moments. So work out the clockwise moments first, which is force times distance, which is 600 times the unknown. The anti-clockwise moments is force times distance, which is 800 times 1.2, which is 960 Newton metres. So therefore, because it's in equilibrium, this 600 times the unknown must equal 960. So the unknown is 960 divided by 600, which is 1.6 metres from the pivot. Okay, so try a couple of questions on this. This is January 06, question 3. Try that. And this one's slightly more difficult, June 2007, question 6.